And okay, so now we are going to, this was the presentation about the first big topic that we are going to tackle here at this conference, infrastructures, research infrastructures. And now we are going to move to the second important topic as a keynote opening. That's going to be AI, and that's going to be tomorrow. The AI is going to be the main topic. And with that, I would like to invite on stage Professor Jan Hajič from the Charles University, the person and head of Institute of Formal and Implied Linguistics and coordinator of Open Euro LLM project. So basically, if you are looking to some newspaper that are at least a little bit tackling the technology things in the last 2-3 months, the article with you was there, you know. So this is really the star and one of the things that's happening from the Czech Republic, and we are trying to coordinate the AI from here. So dear professor, the floor is yours, and welcome on stage.
So good morning, everyone. Thank you for the introduction, which of course was too nice to us. We are not really trying to coordinate all of AI. But what we are trying to do is to work on one project which would bring fully open language models to Europe. So in that sense, it's very relevant for the EOSC initiative, not only in the Czech Republic, but in Europe in general. So what is the project about? Actually, the goals are very simple. So when I am trying to say in one sentence what we are doing, we are developing a single LLM. Of course, there will be variants of it, but a single LLM which will be large enough so that it's of high quality, it is multilingual, meaning that it covers all of the European languages plus some, that it's open all the way from the models down to the data, and it's European in the sense that all the components, even if we will be collaborating, as I will show, with the whole world, will be based in Europe, and there will be no dependence on anyone else throughout the whole vertical from data to the models, which of course includes the compute as well. One additional thing we have to do in Europe is to comply with the European regulations. So at the same time, when we are trying to make them slightly softer, we definitely will have to prove that the regulations are fulfilled so that the companies that will eventually use the product in their applications and innovations will be able to show the compliance, especially for the high-risk applications, and they do not have to worry, at least at the language modeling side. So I think I might not really have to introduce language models to this audience here, but I will just say the very basic thing. So everybody knows ChatGPT or similar interactive models. But of course, behind each of such a model, which is made available as a service, there is the base model, which has been trained on lots of data by using deep neural networks and machine learning. And those base models have, as everybody simplifies, and I will too, the only function is to generate the next word based on a context. But the thing which makes them very different from the previous language models, for example, the statistical ones that have been used in machine translation in the 90s and 2000s, is that the context they can use is much longer, sometimes up to, let's say, 1 million words. At least the best systems can do that. The typical context is a couple of thousand words, and that's something that the previous models were unable to do. And in addition, the context is used in a very clever way. And this was started with the attention mechanism, and there are many, many other ways since then that make the models very capable in saying what the next word is. And of course, another feature that sort of came up just by itself, in fact, is that as opposed to the language as such, the models also model contents, knowledge, right? So this is sort of, in a way, from, if you look at the history, this is a secondary result, but very important because now people use them in various ways for actually looking for contents, for search, for generating things, and so on. So our goal in the project is actually to build the base model, and I will show how it then will proceed to actually have the interactive models and the domain adaptive models. But a base model is just trained on text, so maybe text and images in the multimodal case. In our case, it will be text only. This model actually cannot answer questions. I mean, still have to be fine-tuned to be interactive in the end. But it's still, that's the base product that has to be done to do sort of everything else. So again, from this point of view, the goal of the project is very simple: to have this model with all the features that I said at the beginning, with the whole vertical based on European technology. One question which I'm always getting is how large is how large is a large language model? How do we measure these models? So there are usually many numbers floating around. How many tokens were used to train it? There are numbers in the billions, 12 billion, 400 billion, 70 billion model, and so on. So these numbers typically are the size of the model in terms of how many parameters they use. Now, what is a parameter? Parameter is a real number. Obviously, the real number is represented in the computer in various ways. And of course, there is a quest to have this number represented by as few bits as possible to make the actual inference by the model easier on smaller hardware. So for example, if the latest Llama 3.3, which is some people say equally good as the bigger Llama 3.1, uses typically 70 billion parameters. There are of course smaller variants and others. And those 70 billion parameters, if we quantize it to something less than a byte, will then take 53 gigabytes of memory. So if you have a card which is bigger than that, you can actually fit it into one card, or you can use more of them at inference time. Now, of course, you also have to take into account the context, because as I said before, it is the context that defines sort of the clever behavior of language models, and the context must be also in the memory of the card. And it seems strange that the whole model will take only 50% of the card, but often it happens because you have to have the whole context, of course, converted to embeddings, which are quite large vectors, and then it takes a lot of space too. For training, of course, you have to decide ahead of time what is the number of parameters, at least in the standard way of training the models. And then, of course, you have to have your data. And there is a very simple formula how long this is going to take, at least in the standard case, if I'm not talking about mixtures and so on, where you simply multiply the size of the data by the parameters and by some constant, and it gives you the number of hours on a given hardware. So now let's go back to the project. The Open Euro LLM project is a project which has 20 partners. We are the leading institution, and we are also one of the research places. So there will be a team at our university which will help mostly on the evaluation side. I will talk more about testing and benchmarks and evaluation later. But also will help any other aspects that we have expertise in. And there are 5 more universities. As you see, 2 are from Finland and 2 are from Germany. These are the places which have a lot of experience with building models, especially in the Nordic countries. There are several open models available which are pretty good in their quality. Then we have some research institutes, both industrial and academic, such as Fraunhofer, Germany, the AI Sweden, and then we have companies. So there are 5 companies in the project involved. Probably the most important is Silo AI, who already built large language models with quite good quality for the Nordic languages and usually combined with English. Then we have some smaller companies which have experience with building models or collecting data or both. So this is the commercial partners. And then we, of course, have the HPC partners. Now, of course, the project does not come with the time on the HPC. That's our biggest worry and biggest fight at the moment, that we are trying to secure the compute. But the partners are there because they have experience. These are people typically from the research units, like from Jülich, we have the Forschungszentrum Jülich, from BSc, we have the research unit, and so on. Because those people have experience with using their own HPC hardware with their setup, which differs across the HPCs, for building large models. And this is very important so that we can sort of jumpstart once we get the allocations of using those things, because our experience previously and experience of our partners is there is some lead time, especially if you build something really large. If you build relatively small model or small application, you can do it everywhere, doesn't matter. But once you go over using many of the hardware units, blocks simultaneously, then the trouble starts. And it is very important to have people who have experience how to deal with errors, with even the organizational setup and so on. So that said, we are not the only 20 partners who are building these models. In fact, the project was awarded in a call which was announced together with 2 other calls. So we have a sister project, which is called LLMs for EU, which is to take our language model. Of course, they will start with some other open models, but then they will take our model and will adapt it for interaction, for domains, for maybe more languages, maybe some multimodal features like speech, and so on. And that's called LLMs for EU. It's coordinated by the AltEDIC EDIC. And then also the AltEDIC has a very small coordination action, which should coordinate us too, right? So they will coordinate themselves and us, and then together we should be able to develop within the 3 years the results that I talked about, plus, of course, whatever the LLMs for you will be able to do, like the interactive version of it. So this is the setup. The money which is there is actually more than 80 million euros, because each of the projects is, our project total budget is 34 million, out of which 22 comes from the union. The rest comes from co-funding, either public or private. The LLMs for EU has slightly higher budget with the same limit on the money which comes from the EU. The coordination action is very small, that is 100% funding. And then, of course, we will be getting the compute. And the value of the compute is hard to guess, but we will need maybe roughly the same amount if you divide it for it. So it's not billions. Some people laugh at these numbers compared to OpenAI or the big players. But I'm saying, I mean, you don't need 500 people to develop a language model. I mean, if you have a team of 20, but they know what they are doing, that's probably all you need. Now, of course, you need a lot more people for other things, like the data preparations, collection, especially test data for the evaluations and so on. But you don't need billions for that. What you do need is the compute, obviously, and what you need is the data. Now, for the expertise, we are going even beyond the 2 projects that are funded by this. And we are trying to reach the open source community, because the result should be open source anyway. It just should be based on European technology, but it will be open. So there are various open source communities like Lion, Olmo, the Allen Institute in the US. So this is not limited to Europe, of course, because the expertise is in many, many places. We are setting up, or we already know who the members are of so-called Open Strategic Partnership Board, with whom we will discuss, especially at the beginning of the project. Like now, we will have a call soon. We will discuss their expertise with building open source models and whatever they can give us advice for actually doing so. We will also have to have experts on legal issues, because of the regulations are something that we don't know, or at least we don't know really in detail. And then we will have lots of informal cooperation. So in fact, the data side, and again, we are talking a lot about data here, is very important. And we will not be the ones who start crawling from scratch. That will be impossible, then build a model within 3 years. But we will rely on previous activities, either our own in the past or others who are actually getting data, especially from the internet. And 2 organizations actually stand out, and one of them is CohnCrawl, and one of them is Internet Archive. Now, both are based in the US, but most of the operations are actually running in Europe, so it's easy to talk to these people, and we do cooperate quite closely with them. There are other projects who already built some models, like EuroLLM, has nothing to do with us. Well, nothing to do. Most of the partners we know from other projects, but for example, they have British partners which cannot be part of our project. That's the limitations of Digital Euro, which I don't like, but they are there. And then some of the other communities. For the computing, I already mentioned that we have the 5 Euro HPC partners, but we have to apply for data, at least for now. We are on the way to getting so-called strategic status. So if you know the Destination Earth project, many of you probably do, it already has that status and can ask for some capacities sort of outside of the regular calls. And what is even more important, we could negotiate how to actually use the capacity, not in the usual way where you still have to wait for, and makes it in the elapsed time quite long. So hopefully we will be able to negotiate it. That's what we are working right now. We already got 3 million hours from the AI Factories Innovation Call. I just learned yesterday that we got 1.5 million hours on Lumi for some experimentation. We have 4 more applications pending through the large-scale Euro HPC call, which was closed in April. And now once we get into the strategic part, we will be able to use some of the capacities as well. This is crucial. Without that, we can't do it. We have the calculations. We know how many hours we need, and we will go for it as much as possible, because otherwise we cannot succeed. So that was about the compute. Data. Now, I think on the first slide, I had 32 languages. Now it's 37 because that's sort of the peculiarities of the Digital Europe program bureaucracy, that officially they could ask only for the European languages and the languages of the countries which are in negotiation with the EU to become members. But for example, we couldn't cover Norwegian or the 2 languages of Norway directly, but now we can. So because actually Norwegian University is part of the project, so we added a few languages which are not EU, but which are important. So that's what we are aiming for. Maybe we will extend it, but I don't know yet exactly. The data that we are using, of course, must be open. Now we could have a 2-hour discussion what open in LLM means in terms of the data, because of course all the data, when we talk about textual base model, are copyrighted with some exceptions of public data and so on. But most of it, what you get from the internet, you can use it, you can get it. We have the exception in Europe, but the data is still copyrighted. So there are certain restrictions that we have to follow. But all the sources are open in the sense that at least you can inspect the data, as opposed to many of the closed models or even the open models like Llama, where you actually cannot look at the data. And this is important for the regulations, and this is important in general for open science. So all the data that I mentioned are of that sort, and that we can actually get to it. HPLT. The HPLT data, and which is a bigger and cleaner version coming, is actually a result of another project which we are also coordinating by chance, which is a Horizon data project, and which started before ChatGPT was announced. So the goal of the project was to build multilingual models, but these were the encoder type models. So we will still build them, but that's not so relevant today, even though they are relevant for research applications and students and so on. But mostly the project was converted to creating data for the follow-up projects like Open Euro LLM and creating high quality data in many languages. So in fact, HPLT does not only collect 37 languages, it collects over 80 languages, which we identified that have large enough data to be used actually for LLM training. And there was version 1.1.1.2, 2.0, which is now being used, which is already quite good because it's second in quality after FineWeb. And now we will be publishing 3.0. So this will be one of the sources that we will work with. It's probably much bigger than we can use at the moment, but it's big enough, sort of matches the 15 trillion goal that what we would like to use for the final model in the end, in all languages. Half of it is English and then the other. So of course we will see how that works. Very often the mixture of the data, the sequence of the data that you feed into the training matters quite a lot. We don't have time for experimenting with the big models. We will essentially have 1 or 2 shots for the final model. But we can experiment with models typically between 1 and 10 billion size, for which is what we are doing right now. And then we will see what can be done with the hope that the scaling laws work and that it will transfer to the big model eventually. We are also talking to Open Web Search, which is a European project which does a lot of crawling, and Ostrava knows quite a lot about it, right? And it seems that at least some lawyers think so, that we will be able to use some of the data, not only the indexes in a restricted way, but hopefully that also, I mean, unless there is complete overlap with the data we already have, which could be the case, but we will see, at least we will have another source which is completely European, including the crawl part, because in the Common Crawl is a US foundation, even though they are very, very open and very cooperative, we probably should have a European source of crawls. The other thing which is important is focus on low resource languages. Typically, when you look at the benchmarks and the big models, they do pretty well with the big languages. By big languages, I mean the 6, 7, which have lots of data on the internet, like, you know, of course, English, Spanish, Portuguese, Chinese, and so on. But in Europe, we want to have the languages equal. Of course, we won't be able to do that in full because simply the languages do not have the data, but we will try to even probably do some experimenting. Even Digital Europe is not really for research, but some experimenting how to bring those languages sort of at least closer to what we really want to see from a language model performing in Estonian, Albanian, Bosnian, and so on. Now, of course, in order to score in the benchmarks to be noticed, we will also have to do some fine-tuning. Even though I said the main goal is the base model, but some of the benchmarks you cannot run without that fine-tuning, and for that we will need data, especially native data for the smaller language. So this brings me to the final point, which is evaluation, test data, and benchmarks. And in fact, this will be a big part of the project, probably the most labor-intensive one, because we would like to really create and use benchmarks that are unquestionable. So now there is a lot of discussion whether the current benchmarks, which everybody sort of aims for to compare with ChatGPT and Llama, you know, how tainted they are actually. It's because some of the data was seen in training, some of the data in other languages is just pure translation from English, so it doesn't really follow the cultural and other differences and so on. And since we are really focused on multilinguality, especially European multilinguality, we would like to have these benchmarks sort of clean and unquestionable, at least you know, in the end. Of course, we will have to compare ourselves in using the standard benchmarks. We are hoping to do well there as well, but a lot of work will be done for these. And of course, machine translation will be one of them because we want the model to be useful for that and do better than current models, whether they are specifically trained for machine translation or other are done. Now, we will release the models, even if they are not the best, but if we feel they are useful, they do well in their size category, then we will release some of them. So probably in the summer, we will release like 1 billion ranked models, at least the best ones if they do well, and then gradually we will go to mid-size models, and officially at least next summer we should have one big model sort of pre-released at least for them. And of course in the open source way we will also release all the checkpoints and everything that's sort of around. So that's all I wanted to say. I will be happy to answer questions. Unfortunately, I won't be able to be here tomorrow because I have to be in Netherlands, but I'm here for today, at least up until the afternoon break, I think. So if you have any more detailed question, I will be happy to talk about it as well.
So, thank you very much, Professor. As an open source enthusiast, I have a lot of questions, but the speakers are not here for me, but for you. So I'm opening the questions again. So who wants to ask a question from the audience, please? Okay. Okay, here. Just wait. Sorry, wait for the microphone because for the online participants. Thank you.
Thank you very much for the presentation. I have one specific question. I was thinking, who is, in fact, and especially in your view, the group of those who will be using your results? Whether you expect people to use the released models you just mentioned, because what we see with the classical large LLMs, we are using it as agents, we are using it there. So where you see the major uptake of the result of what we are doing now?
Well, of course, this is a slightly a probabilistic prediction. If I knew, I would probably make a lot of money. But I think there will be three channels. One of them should be, and that's one of even the official goals of the project, should be small and medium companies who will be able to just take the model off the shelf if they have standard interface and everything, and then just use them on premises for applications that, for example, require privacy and so on. So this will be one, and they will have their own developers for fine-tuning and integration and so on. The other uptake I would expect is that there will be a company like Hugging Face, or maybe even more capable than Hugging Face in terms of offering adaptations, meaning fine-tuning, continuous training, and so on, for people who have their data and they want to build their own application on their own data, right? And I think there will be a company or maybe a number of companies who will offer this as a service, and they will use our models, for adapting them and then sort of giving them back to their customers for use. And there might be some even application building companies that might be connected somehow with the fine-tuning agents or organizations. That's not clear. And then I suppose that Hugging Face will be very glad to have them. I mean, we cooperate with them.
If I can just a short follow-up. I mean, you always mentioned companies. I would like to also understand whether in any way we can help also to promote these things within the research community. Like, I mean, setting it up, in our case, in eInfra-CZ, somehow connecting it to some of the repositories which are to be built, to also give the opportunity and then some support, it may go beyond up to the companies you mentioned, to the scientific community to use it. So your opinion on that? Or
I am mentioning companies mostly because this is really one of the activities of the European Union, which is really aimed, I mean, the whole of Digital Europe is meant for industrial uptake. So that's why I'm mentioning them mostly. Now, research people have slightly easier time because they are not restricted by the AI Act, they're not restricted by copyright, they can use the exceptions in full. So they have a bigger choice of using the other models as well. So, but we are of course hoping that if our model is of good quality, comparable quality, has the data open in the sense that people know what they are building on, that it will be useful for the research community as well. Now, of course, we would need, if we are to offer to researchers what this will offer to the commercial world through other, mediator companies, we would need the same thing to have in research. And I'm pretty sure that CESNET or IT for Innovation or even the broader European community especially in open for the open science, if they are able to put together something like Hugging Face or something like easy service for fine-tuning with structural data, multimodal data, private data, whatever, it will be great addition, and that I think would be very useful. But of course, this is something that the individual research groups usually cannot do themselves, especially in non-IT areas, and they would need some helps from us who can actually do this.
Okay, thank you for the questions. I ask if we have any question from the Slido, and then we go with another question from the audience.
We do have a question. You said the Nordic countries already have built multiple base models. Why are we not collaborating on those instead of building new ones?
Well, we We do cooperate with the same people who build the Nordic models, which are in the Silo AI company, who are at the University of Turku, University of Helsinki. And they also want to build bigger models, but the biggest model that is only English Finnish, is 34 billion parameters. And because of the multimodality requirement, we have to do the training in a slightly different way. But they do want to do it, and they teamed with us exactly for this reason, to bring the models, not only for the Nordic languages. Of course, they will use the Nordic languages, but they want to have a multimodal model like that and be the co-authors of it, of course, to have full access to it as well. So just building on their model, even if we limit ourselves to the 30-something billion size, it's probably not, it will not speed it up because it will only go one direction, and it would be not unclear how it will work with the other languages.
Okay, thank you. Next question in the audience.
I actually wanted to comment on the discussion between Ludwig and you, because in material sciences we are starting to build European federative infrastructure, and we want to use LLM agents. And it would be very good to have not to depend on commercial models. We have, of course, our data which will enrich it, but we will need for a native language good basis. So I think this would be very useful. And also, if you can offer later a help, because as you mentioned, this is not so trivial, it would be very useful in a project materials commons.
Yeah, I mean, of course, our anyone from the European Commission, our private goal sort of is also to train people, which of course Digital Europe is not really like the first goal of it, but obviously all partners are hiring junior people to complement the teams who work on the data, benchmarks, training, and the same we will do in Prague, thanks to the ministry co-funding, actually, I should say. And so once we have that team, they will learn, like top level way of building models, and then hopefully they will also, then we will have the workforce who will be able to help people then to do the fine tuning and adaptations.
Okay, thank you. Another question from Slido. I will ask, is there any other question from the audience? If not, so I have one question. Actually, you mentioned the 37 languages, so you are basically building the model in the European context, and that means that there are the decentralization of Europe and languages and states, etc. So is it an advantage against the United States, where there is one nation and one language? It's this kind of advantage in building such models. Thank you.
Well, certainly the US or anyone who has a unified lingua franca has an advantage. That's undeniable. But this is exactly to show, hopefully, that we are able to do it in the multilingual context. So I mean, I was in many European projects before, which sort of, the goal was specifically to have the languages equal in terms of data, services, tools, and so on, like European language equality, European language grid. There were many projects like this. But of course, because they didn't have the technical background, it was mostly coordination actions, they collected some data and so on, but now we need it on a real large scale, especially in the large language model. It is a problem, of course, because everybody knows that if you take an English-only model, which does well on benchmarks, and then you continue training on other languages, the English benchmark goes down, right? So it is always a compromise, and it won't be easy to show that we are still keeping the quality of the English intact, at least to a certain extent, or just, but then we add high quality for the other languages. Yes, it's a challenge, right? And of course, the 37 is a number that we are now committed to. Obviously, we would like to have other languages, at least the big non-European languages, because when I talk about a small company in Europe which wants to grow and wants to do global business, they will ask for Chinese, Russian, Japanese, and so on. But of course, these are big languages, and this all depends again on the compute we are able to get, right? Because the formula for the number of hours you need is very simple and sort of depends almost linearly on the size of the data. So if we add, instead of 15 trillion, 25 trillion, because we have to add these big languages, then we will see whether we can do it. But the European ones are, of course, a priority because it's a European project.
Okay, thank you very much. So last call for the question. Yeah, we have one last question here at the audience. So just a minute, please. Thank you.
Thank you, Jan, for this interesting talk. I would also come to this language again, these challenges to have so many languages. Can you elaborate a bit on the training strategies that you see? Do you throw the different languages just in parallel or in sequence to the model, or do you sort language parts by thematic domains? I have no experience in how this is being done.
So we have discussed it in the first weeks of the project quite a lot, even before when we were writing the project. And there were different opinions, but there were internal discussions. So I shouldn't say who is who, but in the end, it was decided that we will start with English and we will see whether we have the technology in our hands, which includes the adaptations for the particle HPCs where we will be able to work, because that makes a difference. And if we are able to replicate the best results on the small models, then we will continue with English, but we will also try to do on the side some experiments with adding the other languages, because that seems to be a way how not to destroy the English too much. It seems, at least from scientific papers, that if you do the training, that you mix the languages from the beginning, you sort of never reach the top level performance. I mean, again, this might be a speculation, maybe it's a wrong way, but again, given the compute we have to select one.
So it's a bit like real humans learning the mother tongue and adding other languages, or being brought up multilingual in the first place.
Philosophically, yes. But also technically, that seems that it should work. At least it's a proven way, at least for some of the models that were available earlier.
Okay, so this is it. Thank you very much once again for speech and comments. Thank you very much once again. Yeah,